Okay, so in assignment number 2 of our unit on the basics of statistics, we're going to be talking about simple random sampling. So we talked in our last unit about different types of statistics, in our last lesson about different types of statistics and different types of studies. Well, in the different types of statistics, we talked about inferential statistics, where you're able to take a sample and apply that sample to the entire population. Well, how do you know if a sample really represents a population? That's one of the main ideas we're going to talk about in this lesson. So we're going to talk about a representative sample and how it shouldn't be biased, and different types of samples, simple random sampling and simple random sampling without replacement. We're also going to talk about a random number table and a random number generator. All of that in this lesson. Let's go ahead and get started. So before we get into that, though, we're going to review a little bit here before we get started. Let's look at the difference between a descriptive study versus an inferential study. Remember, a descriptive study consists of methods for organizing and summarizing information that's in a population, where inferential study consists of methods for drawing conclusions about a population that's based on a sample. So let's take a look at this particular example. Zillow.com, I don't know if you have seen this, but you can go to Zillow.com right now, and it's just a simple database that provides real estate information for U.S. homes and that are for rent or for sale all over the country. And you can see current statistics on recently sold homes in your neighborhood, as well as in Fort Wayne or in Indiana. But the following table gives various information on all homes sold in several different cities across the United States. So for example, you can see that in Las Vegas, Nevada, this is the price per square foot. In Las Vegas, Nevada, it's only $74 for a home for each square foot. But if you look at San Francisco, $636 if you buy a house in San Francisco. So, man, if you're looking to move to San Francisco, hopefully you've already saved up a lot of money, because housing is just going to be so much more expensive than if you move to Las Vegas. As a matter of fact, they say one of the lowest housing markets is here in Fort Wayne. A house does not cost very much compared to if that same house was in Chicago or San Francisco. But is that a descriptive study or an inferential study? And the answer would be that that's a descriptive study. It's a descriptive study because Zillow takes a look at every single house in the United States that's sold and then summarizes that information. So let's take a look at this particular situation. The U.S. Substance Abuse and Mental Health Services Administration collects and publishes data on non-medical drug use by the type of drug and by the age group. So the survey was done, and the following table provides data for the years 2003 and 2008. The percentages shown are estimates for the entire nation based on information from a sample. Okay, so you can look at hallucinogens. In 2003, we were at 23.3, but in 2008, it went down to 17.7. And so there's a whole bunch of information that you can see here. But the point here is this a descriptive study or is it an inferential study? And this would be an inferential study because it was based on a sample, and they applied the results from that sample to the entire population. Now, whether or not you can actually believe that study, that's kind of up to interpretation. There's going to be confidence tests that we can look at to see how closely we think that the actual population resembles the sample that we took. But the point that we want to take away from this right now is that if we're going to do an inferential study, we want to make sure that the sample that we use, to the best of our ability, represents the entire population. So then we also yesterday looked at observational studies versus a designed experiment. Remember that in observational studies, researchers observe characteristics or take measurements of a sample or a population. And then if that's the case, we can say that there is a correlation, but not necessarily a causation, because there might be something else that's causing the differences between different characteristics within people. Another one, the other example is a designed experiment where researchers impose modifications on one group compared to another group so that the two groups are perfectly identical to each other. The only difference is the treatment that they're receiving. One might receive a particular drug and the other one might receive a placebo. And that is where we can conclude that there's causation, where the drug might be causing certain side effects or a certain treatment to be successful or not. So let's take a look at these examples. Do left-handers die earlier? So according to a study published in the Journal of American Public Health Association, left-handed people do not die at an earlier age than right-handed people. This is contrary to a conclusion of a highly publicized report done 2 years earlier. The investigation involved a 6-year study of 3,800 people in East Boston, older than the age of 65. Researchers at Harvard University and the National Institute of Aging found that lefties and righties died at the exactly the same rate. There was no difference at all. So the Institute and one of the co-authors reported. And so is this an observational study or a designed experiment? There are two groups here. There's left-handers and there's right-handers, but it is going to be an observational study because the researchers did not put them into these two groups. They did not impose treatment on one group and not another group. And so you can have an observational study where you're studying this and summarizing what happens to two different groups. Here it's left-handers and right-handers. It could be male and female. It could be different races. And you're studying the effects of a certain characteristic on a particular group without it being a designed experiment. So this is an example of an observational study. All right, so one more here. The Salk vaccine, a very popular vaccine. In the 1940s and 50s, the public was greatly concerned about polio. In an attempt to prevent this disease, Jonas Salk of the University of Pittsburgh developed a polio vaccine. In a test of the vaccine's efficacy involving nearly 2 million grade school children, half of the children received the Salk vaccine and the other half received a placebo. In this case, an injection of salt dissolved in water was injected. Neither the children nor the doctors performing the diagnosis knew which children belonged to which group, but an evaluation center did. And the center found that the incidence of polio was far less among the children inoculated with the Salk vaccine. From that information, the researchers concluded that the vaccine would be effective in preventing polio for all U.S. school children, and consequently it was made available for general use. Observational study or designed experiment? Well, this is a designed experiment because in the experiment, Jonas Salk imposed a certain drug vaccine on half of the population and then just salt water on the other half, and then looked at the results. And because of this, the only difference was the type of treatment that was provided to these children. We can say that there is causation here. In other words, the Salk vaccine causes the polio to decrease. All right, so today we're going to look at a census study and then a sample study. A census study basically is an observational study that involves an entire population. It's a descriptive study, but a sample study is based on the sample of the population. It's like a descriptive, or it's like an inferential study. And because we're inferring things about the entire population based on our sample, we want to make sure that the sample that we create, that we pick, really does represent the entire population. And so let's take a look at what good samples involve. Good samples should be representative of the population. So in order to understand what good representative samples are, let's take a look at some that are not representative. So for example, let's say at Homestead High School, we wanted to identify what does the average person weigh at Homestead High School. So we just went to football practice and we weighed a bunch of the football players. Would that be a good sample for that particular study? And that wouldn't be, because we would assume that football players weigh more than the average student at Homestead High School. Another example would be if we look at Southwest families. Let's say we're looking at what's the average income here in Fort Wayne. And so we just survey a bunch of people out here in Southwest Allen County schools and found family incomes out here in Southwest. And I don't know if you realize this, but Southwest income is probably a little bit higher than the typical area surrounding Fort Wayne. That would not be a representative sample. We should avoid bias. For example, if we wanted to figure out what was the favorite food in the cafeteria, we wouldn't go to a particular line like the sub line and ask everybody in that sub line, because there's probably going to be some bias towards the sub line in the cafeteria. There's also selection bias. And actually Homestead may have done this several years ago before the band field was built. I think there was a survey done where they asked people to respond to a survey. They asked everybody to respond to the survey on whether or not we thought we should have a band practice field. Well, you can imagine that the band members, they answered the survey a lot more than the regular number of students did, because the band members chose to answer that survey. That's selection bias. You asked everybody, but only the people who really care deeply about that subject are going to really respond to that survey. So that's another form of bias that happens when you're looking for a sample. So there are specific sampling techniques that help avoid bias and help us to better represent the population. They may not completely represent the population, but it helps us get it a little bit better, and that's simple random sampling, cluster random sampling, stratified random sampling, and systematic random sampling. We're going to talk more about these in the coming days and in our next assignment number 3 of this unit. But before we get there, let's just take a look at some simple random sampling techniques. Simple random sampling is a sampling procedure for which each possible sample of a given size is equally likely to be the one obtained. So for example, there's 2 different kinds of simple random sampling. One is simple random sampling with replacement. That means where you might select a certain number of marbles out of a bag, but each time you put the marble back and you mix them up and you select another marble. That's replacing the marble. Okay? Or you can have simple random sampling without replacement. And so simple random sampling is the one without replacement, and that's where you just keep the marble out of the bag. Or once you ask somebody to respond to a survey, they can't respond again. So that's the difference between simple random sampling without replacement and then simple random, just regular simple random sampling. All right, so let's take a look at this example. You want to obtain a simple random sample, so you do it by picking slips of paper out of a box. That's usually impractical, especially when a population is large. So let's say I want to just pick a random student here at Homestead High School. I could put everybody's name on a piece of paper, put it in a basket or something, mix it all up, and then pick one. That would be an example of a simple random sample. But this is not practical because it would take a lot of time to get everybody's name on a piece of paper. So there's other common methods, and one of those methods involves a table of random numbers. So this would be a table of random numbers. Suppose you want to select 15 students from a list of 723 currently in Algebra 2. So we take all the students that are in Algebra 2 here at Homestead High School. There are 723 of them. I can go to a simple random table like this, and let's say I just close my eyes and pick a spot, and I pick this one. So I would number all 723 of those students, and the first person that I would pick is 69. And then I would just go down that list. Now this number right here, I would throw that number out because I only have 723 students. I don't have 988 of them. So this would be my first student that I would pick. My second student would be number 386, and then 539, and then 303, and then 97, and then 628. I could use that number. If I repeated a number, I would just throw it out. If it was too big, I would just throw it out. And I would keep going. I would go down this column, and I would come back up this column, okay, like 849, and then 578, until I finally got my list of all of my samples. Now we can do this with a random number table like this, but there's also random number generators. And this is something that you can do on your calculator. And when we get to class, we will talk about how to do this on your calculator by coming up with a random number generator on our calculator, which is kind of easy to do. And it's kind of I think a lot better than, or a lot easier at least, than doing the random number table. So that's everything in the second lesson. We will do our homework in Math Excel and go over questions in class.